And we are live, you guys. It is Thursday, April 2nd. Oh man, isn't this just crazy what we keep doing? But we're gonna make it work. Think of all the free time you guys have. I mean, you can get your homework done, and then you got a ton of free time. So anyway, let's go through this. So first of all, test 5. If you have not finished test 5, I need that done ASAP. So you've got to get that done. Otherwise, it goes into 0 to the grade book. You don't want that, okay? Let's take a look at the homework from yesterday, and then we'll go through the rest of this, okay? That's my little agenda. So yesterday's homework. All right, here's what I have. It's coming. All right, it's coming. Here we go. Here we go. It's coming. This year's homework. Okay, so first of all, okay, here's number 1. When you graph it, that looks like a parabola. So no, it's not exponential. It's not linear. It's neither. So it's a parabola. 2 definitely looks like exponential. You can see how it grows. It's got that shape, that J shape. Ignore that point. Not there. Number 4, it definitely looks exponential. See, it's got that shape. Number 4, ignore that point. My bad. Looks linear to me. It looks straight. Okay, so you just have to graph and say, does it have that J shape or straight line or neither? Okay. On 5, if you take a look at it, it's going down by 3, down by 3, down by 3, down by 3. So it's got to be linear. And then on 6, you can graph it. What I notice is it's like a times by 6, times by 6, times by 6. So its base would be multiplied by 6, so it's got to be exponential. Okay. 7. I did these. Yes. Here's 7. So I graph 7. Looks linear, and of course if I use my y equals mx plus b, the equation's got to be y equals, let's see, up 3 over 1, up 3 over 1, so y equals a 3x, and it crosses through at 2, okay? Number 8, it's not as easy to tell, but it is exponential. It's growing. It gets steeper and steeper, so if I need the equation, remember, a is where it crosses. It's y-intercept, so a is 7. And if I want to find the growth, I take any second point and divide it by its first point. So I took and I divided 7 by 3.5. So I took this value divided by this value, and I got a 2. So it looks like it is doubling. So I got this equation here, okay? And then 9 sure looks linear. Boy, I would have thought it was linear, but then things just don't increase at the same rate. So I looked a little bit closer. I divided the second one by the first one. I got a 1.05, so it's a 5% increase. Does turn out to be linear. Here's my beginning amount, and it slowly curves. You can hardly even tell it curves, but it will curve. Okay. If you got 9 wrong, it's okay. It's easy to miss out. Okay. All right. So now what are we going to do? Well, I want to show you. We're going to talk about exponential equations. So before I go through this with you, we're going to solve equations like this. Now this is a little weird, so you got to know some things about exponents. So before I do any of these examples, I want to show you this first. Okay, so I took the time this morning to write all of these out. Okay, and you guys can make a picture of this, copy it or whatever, but I need to remember what these numbers are. For instance, 2 to the third is 8. That's because we know that 2 times 2 times 2 is 8. 2 to the 5th is 32. And that's because I took the time to go 2 times 2 times 2 times 2 times 2. And there's 5 2's in terms, so that would be 32, okay? And this is kind of like a lesson you guys did in pre-algebra in middle school. You should know these. Now, another thing is that anything to the 0 power, anything is always 1. You can try to calculate if you don't believe me. Seriously, anything 2 to the 0 power, 1. Anything 3 to the 0 power, 1. Okay? 4 to the 0 power, 1. Anything to the 0 power is going to be 1, okay? So any number to 0 power is always equal to 1, okay? You gotta remember that, okay? Now, I went through the 6's, I went through the 7, 8's, 9's. I didn't need to do the 10's. We might see some other numbers in our homework, but we'll just have to be smart, okay? Now, we are going to talk about negative exponents real briefly, okay? So negative exponents are basically come from fractions. If I have 1 over 2 to the third as a fraction, that's 2 to the negative 3, okay? It's a negative 3 right there with 3, okay? So it comes from a fraction, okay? 1 over 3 to the fourth is 3 to the negative 4, okay? Any fraction becomes a negative exponent, okay? You can even check that on your calculator. For instance, if I went clear, if I went 1 divided by 2 to the third power. I get a decimal, but I can go back and say, okay, well that is the same thing as, well, let's see, 2 to the negative 3. Exact same answer, okay? Exact same answer, okay? There you go. Now, with my chart, I'm going to use my chart to do today's lesson, okay? So let's take a look at some of these, okay? And I'll go through this slowly with you, okay? It says assignment, but it is not our assignment. Our assignment's really out of our workbook. So anyway, let's take a look at number 1. So now, first of all, before we do anything, if we have the same base equal to the same base, then we just cross off the bases and solve. Okay, so let's look at number 1. They have the same base. We got 3 to the 4x and 3 to the 12. If that's the case, we got the same base equals same base. I can cross out the bases and say, well, 4x equals 12. Okay, if we got the same base, crossed off, divide by 4, divide by 4, x equals 3. Easy, right? Okay, same base, I can cross them off. X plus 3 equals 5, right? Minus 3, x equals 2. Easy. Okay, 3, same base. It's got the same base, cross it off. I got 3x equals 2x minus 7. And I can solve. Minus 2x, I get an x equals negative 7, okay? Now, easy. If it's the same base, boom. Just cross off the bases, solve. But when we take a look at 4, it's not the same base. So I want to make it the same base. I need to make the same base. Okay, well, 27. Oh, wait a minute. 27. 27 is 3 to the third. So I'm going to rewrite 27 as 3 to the third. And by doing that, same number, I've made them the same base. So that's what I want to do, is I want to get it to the point where I can make it same base. Then I can cross off my bases, and x equals 3. Okay? 5. Okay, 625. Has to be some 5. I mean, I'll get a little hint here. So I look at my chart. 625 is 5 to the 4th. Okay? Oh, so I'm going to rewrite this as 5 to the 4th. Okay? Same base. I can cross off my bases. Boom, boom. And x equals 4. Now, I didn't put the 11s on my chart, but I'm hoping you know that 11 squared is 121. I'm hoping you know that. If not, there it is. So, if I want to make the same base, 11 to the x minus 4 equals... Hold on. Yeah, Landon. Yeah, I'm recording. Come on in. What's up? Yeah, no problem. Yeah. Okay. Sorry, that's Landon. Wanting to borrow my truck. Let me keep going, okay? So... I've got, back to here, I've got 11. So 121 is 11 squared. So I'm going to rewrite this as 11 squared, but also have the x. See what I did? Here's my 11 squared. Let me circle, okay? Here's my 11 squared is 121, but don't forget the x. Okay, so then, same base. And I got x minus 4 equals 2x, because I cross out my base. If I go minus x, I got negative 4 equals x. Okay, boom. Now, 7. 7 is a little tricky, but we can do it. Now, I see a fraction. So I know I'm going to rewrite this. There's an invisible exponent here. Invisible 1 right there. So it's a fraction. So I rewrite it as 3 to the negative 1. Okay, so 1/3 is the same thing as 3 to the negative 1. It really is. If I see a fraction, it's a negative exponent. So don't forget your x. Okay. 81. Let's see. It's got to be some 3. Look at my chart. It's got to be a 3, right? It's got to be a 3. Looking for 81. There it is. It's 3 to the 4th. Okay. So change this to 3 to the 4th. Okay. Cancel my bases. I get negative 1x equals 4, or x equals negative 4. Because divide by negative 1, divide by negative. Okay. Okay, now, 125, is it a 5? Well, it's got to make the same base. I need the same base. So look at my 5s. 125 is 5 to the 3rd. Okay, so I'm going to rewrite this as 1 over 5 to the third. Okay, 125 is 5 to the third. Okay, now that is a fraction. So again, if I've got a negative exponent, if I've got a fraction, I'll make it a negative exponent. So then I'm going to write this as 5 to the negative 3. Okay, what does that equal? Well, it equals a 5 to the 2x plus 7. Okay, and then I can cancel my 5's. Same base, same base. And I get a negative 3 equals a 2x plus 7 minus 7 minus 7. Negative 10 equals 2x. Divide by 2, divide by 2. X is equal to negative 5. Okay. Again, if I get going too fast, just pause it, think about it, and then start again. Okay, 9. 343 has got to be some 7. I mean, we've got a hint. To solve, it's got to be the same base. So, number 9. 343. I'm looking for 7s. For my 7s. Oop, that's a 343. Haha, it doesn't look like 343. It looks like 343. There it is. I'm glad I caught that. Okay, so 343 is 7 to the third. I can check that on the calculator if I want to, but it is really a 1 over 7 to the third. But that's fraction. So again, I'm going to make it into a negative exponent. So I'm going to 7 to the negative 3 equals 7 to the 5 minus 4x. Okay, once I get the same base, cancel, cancel. I'm going to get a 5 minus 4x equals negative 3, and I got to solve. I can do that. Okay, negative minus 5 minus 5. I got a negative 4x equals negative 8, right? Divide by negative 4, divide by negative 4, and x is 2. Okay, how am I doing? Okay, so far so good? All right. And now, let's do a couple more of these, and then we'll be done. Okay, 17. The 40 is in the way. It's an extra number, so I'm going to get rid of the 40 first. Okay, so 40 is not part of this problem. I've got to get rid of it, so I'm going to divide by 40 first to get rid of. Okay, so the 40 is gone, and I got a 5 to the x minus 2 equals, well, what's 200 divided by 40? I don't know. 200 divided by 40? 5. Kind of thought so. There it is. So I get a 5. Okay. That's a 5 to the 1 power. It's an invisible 1. Got the same base. Cancel the bases. X minus 2 equals 1. Plus 2 plus 2. X equals 3. Okay. Alright, now let's take a look at number 18. The 8 is extra. Divide by 8. Divide by 8. 2 to the x plus 6 equals 4. Okay, I don't need my chart, but if you do, you know, 2 squared is 4, right? We know that one. So I'm going to write this as 2 to the x plus 6 equals 2 squared. Cancel out the same bases. X plus 6 equals 2. Minus 6 minus 6. X equals negative 4. Okay? So again, I want to emphasize that these extra numbers we got to get rid of first. Okay? These extra numbers, let me circle them. These extra numbers you got to get rid of first. These extra numbers you got to get rid of first. So let's get rid of the 3 first. Okay, so I get a 4 to the negative 3x minus 1. Now 48 divided by 3 is 16. Oh, wait a minute. 16 is 4 squared, isn't it? You can use your chart if you're not sure, but 16 is 4 squared. So you're trying to get the same base, so I got to get a 4. So I know 16 is the same thing as 4 squared. You know that. So I got a 4 to the negative 3x minus 1 is equal to 4 squared. Same base. Cancel, cancel. Negative 3x minus 1 equals 2. Okay, I'll go plus 1, negative 3x equals 3. Divide by negative 3. And x equals negative 1. Okay, hey, these are getting fun. Okay, now, let's take a look at 20. Okay, so we got a bacteria, and we will be 81,000. Okay, this is a hard one, but I'm going to do it with you. 162 times 3 to the x minus 2. Okay, so it's like our virus. It's like coronavirus, except for it's bacteria, but you know, they're growing, they're tripling. It looks like they're tripling. So we're starting with 162. How long will it take for it to be, what x value to be that number? So extra number. First things first, divide by 162. Okay, what's 81 100 divided by 162, I get an answer of 50. 50? Really? Well, that's not going to be very good. 50, okay. 50 equals 3 to the x minus 7. And you guys don't really know how to do this, so this is just guess and check. So we're not going to do 20, okay? Forget it. I should have saw that, okay? There's a way to do it, but we'll do this in algebra 2, okay? Now, 21, we can do 21. 2 to the 3x minus 6. 8 as a 2. I know that 8 is 2 to the third. So we're going to 2 to the third with my x minus 2. All right? Just changed 8 into 2 to the third. Same base. I can cross it off. 3x minus 6 equals 3 times x minus 2. Wow, it's going to be all real numbers, isn't it? You know why I know that? I got the same exact equation. This one's tricky, but I got it. X equals all real numbers. Or you guys, sometimes we like infinitely many solutions. Okay, let's see what happens with 22. 9 and 27. 9 is 3 squared and 27 is 3 cubed, so I'm going to go at 3 squared times the 3x minus 2, and I'm going to go 3 cubed with 2x minus 2. Let's see what happens here. Same base, I can cross it off. 2 times the 3x minus 2 equals a 3 times a 2x minus 2. Wow, same thing. All real numbers are infinitely many solutions. Okay, so that is that. The homework you got to work at, and you have to show your work. You must show your work. And it is on page, I'll show it to you. It's on page 176, 1 to 12. Oh, let's take a look. Page 176. And we're going to do 1 through 12. Some of these are pretty easy. They have the same base. But if they don't have the same base, you'll have to find it and get it. Okay, so 112 all on page 176. And that's all I have for today. Tomorrow we'll talk about a review, and then I'll get you the test. Okay, so pause. Please get test 5 done if you haven't finished it.